Good day, guys. It's Miss Summers with the lecture for human impact on oceans. Today we are going to look at a very specific human impact that deals with carbon dioxide and our world's oceans. What you want to take away from this is how are our activities influencing the chemistry and subsequently the biology of the oceans, and why should we care? So let's start by talking about carbon dioxide. We've mentioned this in the past, and it's very important for you as an earth and environmental student to be okay with or know the characteristics of carbon dioxide. It's a very small percentage of our atmosphere, only about 0.04%, but it's a very important gas. Partly because it is a greenhouse gas. Remember, greenhouse gas traps in heat, solar radiation, and sends it back to the surface. So what that does is it warms up the surface of the Earth, which to a certain extent is okay. It keeps our planet at a nice mild, relatively mild temperature that life has become quite accustomed to. So how humans... Carbon dioxide has been around longer than we have been. And in that time, pre-human, natural processes keep carbon dioxide balanced. So some of the carbon dioxide in the atmosphere will dissolve into the ocean, some will dissolve out, some of that carbon becomes incorporated into living things. So there's always been this balance, this happy balance of carbon dioxide in the atmosphere and carbon dioxide in the waters, in the biosphere, and in the geosphere. Okay, so everything's nice and happy balance, and then we show up. No, excuse me. Let's go back here for a second. So here's our balance. Plant respiration and photosynthesis counteract each other. Ocean exchange, some carbon dioxide leaves the ocean, some is absorbed by the ocean. But where we come in to the picture is here. Okay, look here. We have auto and factory emissions, all right? These emissions can be the result of burning things like fossil fuel, oil, coal, natural gas, all that fun stuff. And what that's done is we've added more carbon dioxide to the atmosphere. So there's not really any arrow that we've added that takes carbon dioxide out of the atmosphere. We are consistently putting carbon dioxide in. So what that does, we have more carbon dioxide in the atmosphere, which we know because carbon dioxide is a greenhouse gas. That means more heat is going to be trapped, increasing the average temperature, and that comes with its own slew of problems. But we're going to look at the excess carbon dioxide that ends up in the ocean. All right, so this carbon dioxide ends up in the ocean. This blue arrow here, this blue arrow has gotten a lot bigger. And what that does is it creates carbonic acid. Now, carbonic acid, like any acid, will drop your pH, so your water is now more acidic. And we call this process ocean acidification. Okay, so the process of the oceans becoming more acidic. For some reference on how quickly this is occurring or how much of a problem this is, over the past 2 centuries, it's about 200 years, from the time the Industrial Revolution began and we started burning coal like it was going out of style, to present day, the ocean pH has dropped from 8.2 to 8.1. And you might be saying, well, that doesn't seem like a whole lot. That's 1/10 of a point. But what you got to remember is pH scales are logarithmic, which means for every 1 point value, that's a 100-fold increase or decrease. Okay, so if you're going down, that's an increase in acidity. So that change of 0.1 in average pH is actually, the oceans are 25 times more acidic. So it's actually sort of a big deal. All right. The reason this chemistry change is a big deal is because it's going to affect our living organisms, our friends who live in the oceans. So all the animals that live in the ocean that have calcium-based structures, so things like snails and nautiluses and oysters and things like that. Any crustaceans, coral, some plankton. It's going to break it down. So if you remember from the lithosphere unit, we looked at limestone and how limestone weathers a lot faster, especially in the presence of acid. Limestone is made of the same stuff that these guys are made of, calcium carbonate. All right, so if you need to see this, take a piece of limestone or an oyster shell. You can buy them at like Tractor Supply stores. Oyster shells, fun fact, are used in chicken feed. Just add that to some vinegar and you can see how quickly it breaks it down. So here is a shell of a nautilus type thing, and as you can see, after about a month and a half, it's completely broken down. And this animal cannot live in this thing, so it will die. So why that's a problem, remember plankton, oysters, these smaller animals, are food for other people, or other organisms, not just people. So if your critters down here at the bottom of the food chain, your phytoplankton, your zooplankton, your mussels and oysters, if they die, that means your small fish, your fish larvae, your top predators, they no longer have a food source, and that's a problem. Why it's a problem for us, so all these animals are dying, that's going to eventually reach back to people on land. All right, if you remember, we've talked about where people tend to gather and migrate, and people tend to live on coastlines because that's where a lot of money is. You can build economies there. There's a food source there. We've built million-dollar industries around oysters and mussels and clams and all that shenanigans. Fish that feed on these calcium-based, these animals with calcium-based structures. If they die off, the industry has no supply. And if they have no supply, they have no product to sell, and they make no economic contributions. And then they're out of jobs, and that's an even bigger problem. All right, so all of this is not just an environmental problem, it's a very real economic problem. So what can we do? All right, again, I'm a big advocate of talking about problems and solutions. If we know that ocean acidification is caused by excess carbon dioxide, in order to curb that acidification, we should emit less carbon dioxide. So think about ways that you could emit less carbon dioxide. Maybe you don't burn as many fossil fuels. How could you do that? Well, maybe you don't drive as much. Maybe you carpool places. Maybe you walk or bike instead of driving. In terms of the fossil fuels that we burn for energy, if you have the capability and the means, instead of using a fossil fuel, getting your electricity from a fossil fuel fired power plant, like most of us probably do now, things like solar or geothermal or wind energy, those investments will reduce our dependency on fossil fuels. And if we can reduce that dependency, we reduce how much carbon dioxide we are contributing to the atmosphere. All right, if you have any questions, just let me know either in the comments or in person, and I will see you all later.